Let's look at the NN2 shellcode. NN2 shellcode is very similar with NN1. Then first, the transfer function, I just used the same thing, but if you look at the tips at the end of the NN2 paper, you're gonna see a better way to write down this one. Then the product I just used from the NN1. Then for the bidding, instead of the evaluate, now I'm using for the bidding, FF. But before I call this FF, now I have to evaluate until the last output and store that. Then I cannot use for last input and store that. I need the full structure, so it's gonna be a little bit different from my NN1. Then also at the end of the each for the bidding, I need to calculate the error of that for the bidding, that one training set. So I'm going to return the current X values and error value after my for the bidding is done. Then backpropagation will use a training set, the current X values, current weights, then current E node values and negative gradients. So the last two is for the structure to modify or store the value. Then I'm going to run the backpropagation. So starts from at the end and by using our formula, then evaluate each one and finally filling out the E values, E node values and negative gradients for each wire, then return those two lists. Then update weights. Previous weights are needed because we are going to add new values to the previous weight, and we also need the negative gradients of each wire, then alpha values. By using those three, we are going to update the weights and return the new weights. So by using those methods, we can train the whole network and make the network better. First, it has only one input text file. Then transfer function, we decided to use only T3. Then training set is given from the file, but there are multiple training sets, so you have to read all of them and store in one place is good. Or if you are using NN class, you can think about how to store those values differently. And layer count is required. Hidden layer is always a 2, 1, but first one and last one can be different. The first one will be your training set 0. Actually, my training set 0 already has one more for the bias. Then layer count will be printed. Now, by using the layer count or training set, or both of them, you can set X values and weights. X values, you can think about all the nodes. So in this diagram on the right side, 1, 2, 3, 4, 5, 6, 7 X values you need. First layer, 3 X values, second layer, 2, and third layer, layer 2, has only 1 X value, and output layer, 1 X values. So you can see there's one example. First, in my code, I start from the original input, and finally, when I print X values at the end, it has the whole structure of the one for the bidding network. Then, by using the second input, add bias, then second X value structure. For the weight, you can just think about the one structure values because you're going to update the same weights again and again, use the same weights again and again. So by using your layer count, you are going to get the random values, and finally you are going to see it looks like this kind of weight. So everything in one list in the weight. Then we can also build the backpropagation network structure first. So if you are making the NN class, you are gonna do all of these in the init. Then evals will have the same structure as xvals. So just copy everything from xvals and then change later. The negative gradient, you're gonna copy every element from the weight, then you can change it later. Okay. Then we need the errors. So I said we need the error list. If we have 4 training sets, error list will have 4 cells to store each training set's error. So in this case, I'm gonna multiply just training sets, length of the training set times like a high enough value. So my list will have like a, in this case, 10, 10, 10, 10 in one list. Then I'm going to use a count for use. We can also use a count for the index calculation or decision making or restart. So if I cannot reach the goal, but if I did it too many times, I can change my count. I can restart by using the random values. Then also the starting is very important. So you probably want to calculate if your first weight you choose randomly is best or not. So you can just do the all board feeding. So board feeding like a 4 times if you have a 4 testing sets, then calculate all the errors, then you're gonna get the sum of all those errors. If this error already met the goal, like a 0.01, you're done, you don't have to worry about. If it did not meet, you can think about if error is too big, you're gonna reset all the weights with the random values. If it is not too big, you are going to start the backpropagation. This is just like how to start well. Then you can think about other way too. This is just one of the suggestions, not requirement, not mandatory. Next part is also not mandatory. This one try to explain what structure you may need to train your values. First, you are going to keep doing until you do not meet the goal. Then you are going to update xvals and errors by calling the for feeding method. Then you are going to train whenever your error. So if I have 4 training set, whenever I'm done 4 times, I'm going to calculate the sum of the errors. Then I'm going to check if I need to stop or not. Then if you don't need to stop, you are going to keep doing. You are going to do backpropagation, so update the evals and negative gradients list. Then by using those, you are going to update each wire, each weight. Then you are going to do forward feeding again. So actually your order is do backpropagation, update weight, then do forward feeding, then check the error. So backpropagation, wait for the feeding, check the error. That's actually what you're supposed to do each time. Then if error sum meets, then each time I recommend to, if you're using count, I recommend to increase the count. Then you can also use the count value to restart or not. Then finally, when you're supposed to print is weight values. So you can refer your Lab 02 and then 2. You are supposed to print the layer count. Then if I look at the last page, you are supposed to print layer count and all the weights. Actually, errors, you don't have to print it. It's not required. So this is all you need to do for Lab 2. Then you have many ways to do that, and one of the popular ways will be introduced by the guest lecturer that is using the class. So we are going to talk about that later in class.